Hey Alex, how's it going?
Hi Jen, good to see you.
Yeah, so I was looking at the ASCT document and I happened to notice that there's a Surface Geophysics case study. And so I was wondering if you could kind of talk through that.
This is a site up in Northern Virginia in the Piedmont town, and the center of the town is provided with municipal water, but the surrounding area, the residents, are mostly on private drinking water supply wells, and is weathered bedrock over fractured bedrock. The groundwater's in the weathered bedrock and it extends down to bedrock. We became aware of it when a real estate transaction identified that a mostly out of use supply well on a gas station contained really high levels of MTBE. And we were concerned because there are about 30 wells within a quarter of a mile of this gas station once you get beyond that immediate municipal area. And I can show you here on the computer. The central area here in the blue is where the municipal supply is, and then out here in the exterior is where it's private supply. There's about 30 wells within that quarter of a mile, so it's a high risk location.
Right.
And justifiably the local community is concerned about their groundwater quality. So we reached out to the responsible party and they sampled all of those wells and they were all clean. So that was the good news. And so we started the investigation, and over 4 years found that there's significant MTBE contamination in the shallow groundwater in the weathered bedrock, and then there's also MTBE contamination in the deeper bedrock. So there's a possibility for movement in fractures in that bedrock.
Well, and I would imagine too with those receptors that those fractures present a really obvious conduit for contamination too.
Yeah, potentially. And so that's what we needed to find out about.
Right.
Now the other problem that we had was the commercial properties around the gas station were not very keen on having lots of wells drilled on their property. So we had great difficulty getting off-site wells. So our investigation was pretty much limited to the gas station itself. And the community was concerned that essentially we hadn't properly characterized the full nature and extent of the contamination, particularly with this fracture flow issue. So we had a quandary. How could we investigate that off-site issue? The responsible party's consultant suggested using Surface Geophysics, and we thought that was a good idea. They suggested three main techniques. They suggested electrical resistivity, multi-channel analysis of seismic waves, and seismic refraction. And they chose three techniques because they wanted to have multiple lines of evidence, and they also wanted to be sure if one technique wasn't effective, there were other techniques that would provide them with the information. So we had to find out a little bit more about those techniques because we needed to be sure that they could get off-site access. They essentially didn't have to do any damage to off-site properties. They wouldn't disrupt any off-site users' use of their properties, because all they have to do is they lay out cables for both the resistivity and the seismic techniques to have the cables provide the sondes along those investigation lines, and so it's very low impact. And then in order to generate a signal, electrical resistivity generates an electrical signal that's received by the system, and then the seismic systems, they just have a hammer, a sledgehammer, 20 pound sledgehammer that they hit against a metal plate, and that generates the signal. So low impact, no disruption, community is not concerned, no complaints, and it can be done very quickly. So this investigation took just 3 days. And the other key aspect is that as I said, we spent several $100,000 on investigation so far, so there's a limit to how much funding we had available. And this technique, the 3 days of work they did, was cost them approximately $15,000 to do that work. So that was a good plus for us.
Mm-hmm. So did you use any of the previous data that you had collected during the phase 2 to tell you where to put the surface geophysics lines?
Yes, so the downhole geophysics work allowed us to confirm that the general fracture orientation was in a northeast-southwest direction, and so they were laid out the survey lines at about 90 degrees to that orientation. So that allowed them to most accurately map the fractures that were there.
So what did each of the techniques kind of tell you?
So each technique gave us some valuable information, but the electrical resistivity was most effective at finding where the weathered bedrock ended and the fractured bedrock started. It didn't tell us too much about the actual fractures in the bedrock. The two seismic techniques complemented each other to provide good information on where fractures were, and essentially they located one significant fracture system running roughly north-south, and we were able then to have the responsible party drill monitoring wells in that fracture system that allowed them to map out both how groundwater was moving in that system and whether or not contamination had moved a significant distance from the site. And we're able to show that it hadn't, and also then allowed us to verify that the corrective action plan that had been prepared for the property was going to be effective in containing the contamination and allowing it to be reduced. And it gave the local community a lot of confidence that now the problem was reasonably well characterized and that their wells were most likely not at risk.